This is star delta ladder logic, a reduced voltage motor starter running live. Right now the motor is starting in star, a timer is counting, and any second it will switch over to delta for full speed running. By the end of this video, you will be able to build this exact program, rung by rung, and explain every contact on it. Star delta is one of the most common starters in any motor room. 3 contactors, 1 timer, and a switchover you have to get exactly right. So let us rewind, wipe the diagram clean, and build it from the very first rung. First, why bother with star delta at all? Start a big motor straight across the line, and it slams the supply with 6, 7, even 8 times its running current, enough to dim the lights and trip breakers. The fix is to start it soft. In a star connection, each winding sees the line voltage divided by √3, so the motor pulls only about 1/3 of the starting current and makes about 1/3 of the torque. It gets the load moving gently. Then once it is up to speed, we reconnect the windings in delta. Full voltage, full torque, full running power. 3 contactors do the switching. KM1 the main, KM2 for star, and KM3 for delta. Here is what star and delta actually mean at the motor. A 3-phase motor has 6 terminals, the 2 ends of all 3 windings. Tie the 3 tails together at a common point and feed the 3 heads from the line, and you have star, sometimes called Y. Each winding now sees line voltage over √3, about 58%, so the current and torque drop to roughly 1/3. Wire each winding end-to-end in a closed loop instead, and you have delta. Now every winding sees the full line voltage, and the motor makes full torque. So star delta starting is really just this. Start and star to go easy, run in delta to go hard. The entire job of our ladder is to flip between those 2 connections safely. Rung 1 is the control seal in, and it is exactly like an ordinary start-stop. Off the left rail, a normally closed stop button, then a normally open start button, then a normally closed overload contact, feeding the main contactor coil KM1. Tap start and KM1 pulls in. In parallel with start, we add KM1's own auxiliary contact, the seal in, so the moment KM1 energizes, it latches itself on, and you can let go of the button. KM1 is the master switch for the whole starter. While it is in, the motor is connected to the line, and every other rung hangs off it. Press stop or trip the overload, and KM1 drops, killing everything downstream at once. The instant KM1 seals in, we start the clock. Rung 2 is a normally open contact of KM1 feeding an on-delay timer, a TON. Its one job is to measure how long the motor stays in star before we hand over to delta. Give it a preset, here about 6 seconds, and while its input is true, the elapsed time climbs toward that preset. The moment elapsed time reaches preset, the timer's done bit fires. That done bit is the entire brain of the switchover. While it is off, we are in star. The instant it turns on, we drop star and bring in delta. 1 timer, 1 decision. Rung 3 energizes the star contactor, KM2. The conditions are 3 things in series. KM1 must be in, so the motor is connected. The timer's done bit must still be off, and critically, the delta contactor KM3 must not be energized. So the rung is a normally open KM1, a normally closed timer done contact, and a normally closed KM3 interlock, all feeding the KM2 coil. When you press start, all 3 are satisfied instantly. KM2 pulls in, and the windings snap into star. The motor begins to turn, drawing that gentle 1/3 current while the timer counts up in the background. Now the moment everything is built around, the switchover. The timer's elapsed time reaches its preset, and the done bit fires. Watch the star rung. That done bit is a normally closed contact, so it snaps open, and KM2 drops out instantly. The star connection is broken. For a brief dead time, just a few tens of milliseconds, both star and delta are open deliberately, so the star contacts fully part before delta ever closes. Then on the delta rung, that same done bit is a normally open contact, so it closes and pulls in KM3. The windings reconnect in delta, and the motor surges up to full voltage and full running torque. star, timer, delta, the entire handover in one clean move. Let's look at that delta rung on its own. Rung 4 energizes CAM3, the delta contactor, and its conditions mirror the star rung. CAM1 must be in, the timer done bit must now be on, so the star phase is finished, and the critical one, the star contactor KM2 must be dropped out. So it is a normally open KM1, a normally open timer done contact, and a normally closed KM2 interlock in series to the KM3 coil. Once KM2 has released and the done bit is set, KM3 pulls in and seals the delta connection. The motor now runs across the full line, exactly as if it had been wired in delta from the start. This is the rule you can never break. KM2 and KM3 must never be energized at the same time. If star and delta close together, you short two phases of the supply straight through the contactors, a dead short, a flash, and trip breakers at best. So we interlock them. Each contactor carries a normally closed auxiliary of the other, wired into its own rung. KM3's contact in the star rung, KM2's contact in the delta rung. So one physically locks the other out. Whichever closes first, its normally closed opens and blocks the second from ever pulling in. On real starters, this electrical interlock is backed by a mechanical interlock too, a bar between the two contactors, so they simply cannot both close. Belt and braces, because the cost of getting it wrong is a bang. So how does it all stop? The same way any motor starter does. Press stop and the normally closed contact in rung 1 opens, KM1 drops, and its seal-in collapses, and because every other rung hangs off KM1, star, delta, and the timer all fall away with it in a single scan. The overload does the identical thing. If the motor draws too much current for too long, the thermal overload heats up and its normally closed contact snaps open, dropping KM1 and shutting the whole starter down before the motor cooks. One master coil, one clean shutdown, whether it is a person or a fault that pulls the trigger. Let's watch the finished program run end to end. Press start. KM1 seals in and the timer starts. KM2 pulls in and the motor begins in star, drawing its gentle third of full current. The timer counts up, the done bit fires. KM2 drops a blink of dead time, and KM3 pulls in delta, full power. The motor is now running at full torque, and it will stay there until stop or an overload drops KM1. 4 rungs, 3 contactors, 1 timer. The complete reduced voltage starter. And none of this is abstract. Every symbol is a part on the panel. Coil KM1 is the main contactor that connects the line. KM2 is the star contactor, which ties the 3 winding tails together to make the star point. KM3 is the delta contactor, which cross-connects the windings into a delta loop. The TON is a timer relay, pneumatic, electronic, or built into the PLC. The overload is the thermal relay bolted under KM1, watching the motor current. And the load is a 6-terminal motor, U1, V1, W1 at the heads, U2, V2, W2 at the tails. And the way those two contactors join them is the whole difference between star and delta. Read the ladder, and you are reading the wiring. So there it is, star delta ladder logic, the whole reduced voltage starter in 4 rungs. KM1 seals in as the master. A ton times the star phase. Its done bit drops KM2 and, after a dead time, brings in KM3. And a hard interlock guarantees star and delta never close together. Want to go deeper? I have a full build on start-stop motor control ladder logic, one on reading a motor single-line diagram, and one on the VFD, the modern soft start alternative, all linked below, and they all sit under the ladder logic hub. And to run this program scan by scan, with the timer ticking and the contactors switching live, our sister PLC simulator does exactly that. Open the free editor, drop in the 3 contactors and the timer, and build this starter yourself. The link is in the description. Subscribe for a new diagram explained every week, and I will see you in the next one.